Okay, so reaction rates are going to vary through the course of a reaction. So let's say at the beginning of the reaction you have a bunch of reactants and eventually they're turning into products. And the concentration of your reactants are going to decrease over time. And as we know, the less reactant particles, the fewer the collisions, the slower the reaction becomes. So the rate of a reaction is not constant from start to finish. Initially, it's very, very, very high because you have a lot of reactant particles, but over time, it's going to slow down because you have fewer and fewer reactant particles to collide and cause a reaction to occur. So we have this thing called instantaneous rates, which is if we took a snapshot of a given reaction at a given moment in time, what would the rate of the reaction be at that time? So it is the rate at a specific moment in time, and graphically, it will be equal to the slope of the line tangent to the curve at the given time. So here in the graph, we have concentration plotted on the y-axis and we have time on the x-axis, and they want us to calculate the instantaneous rate for the reactant at 100 seconds. So I have three curves. Nothing is labeled reactants or products, but I can use some intuition here. If I start only with reactants, I can deduce that the green curve is the reactant. We start off with a lot of reactants, and over time, its concentration is decreasing because they are being consumed. And then the blue and the red lines represent products because their concentrations initially are 0 and they are increasing over time. I can label that a product and a product. So at 100 seconds for our reactant, so I go to 100 seconds, I go up to our reactant, I'm going to draw a dot. And on your graph, it already has a straight line drawn tangent to that 100 seconds. And the rate at that moment in time for the reactant will be equal to the slope of that line. And remember, slope is rise over run. So we're going to take the rise of the change in y, 0.0026, and divide it by the change in time, which is your run, 110 seconds. Okay, so it's going to be 0.0026 molar over 110 seconds. Now this is going to be a negative value because the slope of this line is negative. It is going down. So I get an answer of negative 2.4 times 10 to the negative 5 molarity per second. And it is going to be a negative slope because the amount of reactant is decreasing over time. Number 2, calculating the instantaneous rates of NO at 250 seconds. So I go to 250, I go up to NO, that's going to be the blue line. And I've already drawn a line tangent to this curve. And again, rise over run. Change in our y over the change in our x. This is going to be a positive slope because this is a product. The concentration of product is increasing over time. I get 9 times 10 to the negative 6 molar per second. Then finally, number 3, calculate the instantaneous rate of oxygen at 250. So at this moment in time, it's going to be a positive 0.0003 over 70 seconds, 4 times 10 to the negative 6 molar per second. So again, to recap, you have instantaneous rates, which are rates at a specific moment in time. And the reason why we can calculate instantaneous rates is because the rate is not constant throughout a reaction. The slope of our lines are going to be really high at the beginning of a reaction, but then eventually, like you see here in these curves, the curves get flatter as the reaction proceeds, and because that's the reaction slowing down because there are fewer and fewer reactant particles available for collisions.